That's from WireFlow, and I'm going to demonstrate one of the features of the Lundby Data Logger system. The Lundby Data Logger system is a distributed and synchronized logging system. And for the presentation, we're going to use this setup, which is a presentation PC running the Lundby user interface and the Lundby streamer service. And the Lundby user interface is responsible for configuration and monitoring of the logger tasks, and the Lundby streamer service is responsible for fetching ready log files from each of the logger nodes in the system. We do have a main switch that's acting as a time master in the system, and then we have two logger nodes, each running its own I/O. And between the main switch and the logger nodes, we're using a time-sensitive network, especially the feature IEEE 802.1 AS, to get all the nodes in the same time synchronization. In this demonstration, we will start logging while the node is disconnected. And the scenario is that we have two systems, and one of the network cables are disconnected, so a connection to a node is lost. And while we're disconnected, a logging action has been started and it should actually be logging data over all logger nodes. After a while, the network connection is restored, and now we're going to see what happens and demonstrate the usage of the pre-triggering buffer in the logger nodes. So once the network is restored, the second node should show up again. And the second node detects an active logging session and start logging data from the trigger time using its pre-trigger buffer to get data from the time the trigger was started. We're going to check the received logger files to show that there is no loss of data and that the offline node has picked up logging and used the pre-trigger buffer to get data from when it's disconnected. For this demonstration, the pre-trigger buffer is set to 1 minute, and hopefully that will be enough. So this is the original system. We have station 0 and station 1 both running, both in sync with the system. So let's disconnect station 1. So we see that it freezes, and now we're just waiting for it to get yellow, indicating that we have lost connection to station 1. And once we get this disconnection, we're going to wait like 20 seconds. And while it's being disconnected now, we are actually going to start this trigger. So let's start the trigger for this demonstration. We see that station 0 picks up and starts logging data. We see that we have one node actually logging data at the moment. And now we're going to restore the network to this station 1. So here we go. I just plugged in the network cable again. And station 1, we just wait for it to turn white, and just you see that it immediately picks up and start logging data. We have two logger nodes running this logger action, a logger task. So let's stop this and see what's happened. So if we now check the local log files, we will see that we do have a lot of log files in the system. A lot of log files in the system. We see that we got a station 0 at a trigger at 4 minutes after 9, and that's actually the UTC time, so it's different time here in Sweden right now. And if we check on station 1 that was disconnected at the time of this trigger, we see that it got the same trigger time, 4 minutes past 9. If we open up this TDMS file in Excel, we're going to see in just a minute. Here we go. So if we check the first sample of this one, and we just scroll to the right a little bit, we see the start time of this data is 11:03:41, and the file itself started. The trigger came at 4 minutes past 11, but since we have 1 minute pre-trigger, the data is actually from 11:03, and that's in Swedish time, not in the UTC time. So this actually demonstrates that even if a node is disconnected while a logger task that involves this node is started, it will still pick up data from the time back in time thanks to these pre-trigger features. Thank you.